Hello everyone, I'm Pragati PH. So I'm here to present my assignment 1 of Automata Theory and Computation. The topic of my assignment is Mini ATC Lexical Analyzer and Phraser. So in this project I implemented identifier recognition, lexical analysis and basic phrasing using automata theory and context-free grammar concept. So the main objective of our topic is to understand how programming languages are processed. The lexical analyzers identifies the tokens such as keyword, identifiers, delimiters, operators. The phraser is used to check whether the mini ATC program follows the correct syntax rules using context-free grammar. In this assignment, it is divided in three main parts like level 1, level 2 and level 3. In level 1, I implemented a identifier recognition using a finite automata. A valid identifier must start with a letter and may contain the letters and digits. For test cases like for valid identifiers x and total 1 because they are starting with the letters. For invalid identifiers we can use as 1x and $b because it's starting with a digit 1, and in second example it is using a dollar like a special character, so they are the invalid identifiers. So I have a program based on that to check whether a valid or invalid identifiers, which is in a C program. Let me share the screen. Yes, this is a level 1 C program, a C programming code. Here in the output section we can see enter a string total 1. It is shown valid identifier because it's starting with a letter and it is also containing a 1, like it is also containing a digit. So if it is starting with a letter means it's always a valid identifier as we seen in the test case. So I have another example. These are the screenshot where I run these programs in online compiler. Yes. So this is the second example. Uh, Same program I have given a invalid one. Here we can see B at C. I have used a special character in between the letters. So it is showing a invalid identifier. This is what we have implemented in a level 1. Next, level 2. In level 2, I implemented the lexical analyzer. The lexical analyzer reads the mini ATC program and generates token. Token is nothing but it is the smallest programming language. It includes keywords, identifiers, numbers, operators, and delimiters I I explained in the objectives. So how it works in level 2, again I have another code. So this is a level 2 program. Again I have used a C programming language only. uh, if we observe the output, enter mini ATC code end with ash. So while giving the input, it should end with ash. Begin int x, x is 10, print of x and ash. So this is the input we have given and this is the output. So in second phase, it will analyze the input and gives that what are the keywords, what are identifiers, what are delimiters and what are operators and what are numbers. Here we can see keyword begin, keyword in, identifier is x, delimiter is semicolon, again identifier is x, operator we have used is equal, where we have used equal here. Then number is 10. IN delimiter semicolon. Keyword print delimiter open and close bracket semicolon. So this is what in we have done in the level 2. Like here we using a lexical analyzer which reads the mini ATC program and generate the tokens. These are the tokens. Next in level 3, I implemented both lexical analyzer and Praiser. As we know what is lexical analyzer, then what is Praiser? Praiser is nothing but it validates the syntax of the mini ATC program using context free grammar. So how it will? So for that also I have a program. Yes, this is the program for third level. Here we can see enter mini ATC program begin index existent printx and it is ending with a unitary operator. So the praiser checks the program start with begin and contain valid statements and end with end. So here in our input we have both begin and end and have some statements. So uh, in the code we have used str function, so which is used to identify keywords and operators. As we see in the output it is showing the keyword operators, right? So this is because we are using the str function. Tokens are generated during lexical analysis. So praisers check the syntax condition. If rules are satisfied, it will show a valid input. If otherwise, it will show invalid input. So as we are seeing here, it contains all begin and ending, like it is following all the rules correctly. So generating tokens, it's showing the what are keywords, what are operators, and it is a valid mini ATC program. So here the program is accepted because it follows the context free grammar rules. Another one I have a input using a invalid example. So this is the output of invalid program. So let's see what is missing here. So again enter mini ATC program begin index existent print of x and unitary operator is closing here. So as we can see here they have not used end operator. It is analyzing water keyword and operator by lexical analysis. So it shows the invalid program. What is invalid here? Missing end, right? Here end is not included. So it will show a invalid program because end is missing. This is how our three levels works. So in this assignment it helped me to understand what is lexical analysis, what is a praiser, what is finite automata, what is context free grammar, and used in how praiser concepts are used in compiler design. So this is all we have seen, and thank you.